We're going to work on lessons 9 and 10. So you need this packet. It has lesson 9 and 10 here, and then a second page of lesson 9 and 10. So we're going to start on the front. So have that ready, get your pencil. I'm going to remind you of something as we get started. What we're going to work on is called simplifying fractions. There's a couple other words. It might be reduce or rename. It just means take the fraction that you have. If you're going to simplify or reduce, it means make it smaller. You're going to make an equivalent fraction, which you've been doing, but it's where you put it in the smallest form that you can. All right, so you're going to hear the word and you're going to see the word simplify a lot. It's sometimes called rename, which just means give it a new name, or reduce. Okay, so before we get started on that, I want to look at factors. Remember that factors, I guess before I show you this, factors are what we use to multiply. So we use factor, factor, product. Okay, so a factor times a factor equals the product. So that could be anything like 2 times 3 equals 6. So the factors are 2 and 3. Okay, and when I multiply those together, they equal 6. So factor is anything that can be multiplied by each other to equal something else. If I'm looking for the factors of a number, I'm thinking, what can I multiply by each other to equal this number? Or if you go backwards, you can think, what is this number divisible by? All right, so I wrote a few numbers and we'll work on these ones. I want you to think about the number 4. What are all of the factors of 4? What can you multiply by each other to equal 4? We always know the first two factors. What are they? 1 and the number you have. So I know 1 and 4 are both factors. Okay, and then I just kind of count up to that number. If it's an even number, I always know that 2 is a factor. So what times 2 is 4? 2. 2 times 2 is 4. I only need to write it one time. Okay, then the next number we have it before we get to 4 is 3. Can 3 go into 4 evenly? Can you multiply it by anything to get 4? No, so it's not a factor. So the factors of 4 are 1, 2, 4. Okay, try it with 10. What are the factors of 10? Should have said 1 and 10, and then start at, is this odd or even? It's even, so I know 2. 2 times what? 5. Okay. Now, because I have half of it, I only have to go up to that number. So 3, anything times 3 equals 10? Nope. 4, anything times 4 equals 10? No. And then I'm at 5. I've got it. I know it won't be more than that because 2 times 5 equal 10. So there's no other number in between there that can be multiplied with the numbers that I have below it. That's kind of an odd way to explain it. But as you look at the factors, as you think what can be multiplied by each other, that's where it stops. So you can also remember that you could use your multiplication chart. That could help you too. Like look at 16. If you have a multiplication chart close, you can look at that quickly. I wouldn't stop the video to do it because we're just going to be thinking about them. But as you're doing it on your own, as you're simplifying fractions, if you need the multiplication chart, grab that out. Look at 16. Anywhere that 16 shows up on your multiplication chart, you'll be able to find the two numbers that made it. So what's the very first two very obvious factors of 16? 1 and 16. What kind of number is 16, even or odd? Even, so I know 2 will work. What times 2 is 16? 8. Something like that. Okay, and then I'm just going to count up from there. 3, can 3 go into 16 evenly? 3 times 5 is 15, so I wouldn't be able to make 16. What about 4? What is it? 4 times 4 is 16. What about 5? I know it doesn't go in here because in order to be a 5 to be a factor of it, has to end in 5 or 0. What about 6? I know 6 times 3 is 18, so it can't be 16. It won't go that close. 7? 7 times 2 is 14. There won't be enough to get to 16, and then we're at 8. Okay, so those are the factors. You're going to be working on that today. I just want to remind you how to do that. All right, so we're going to start with this. We're going to go through it, and I'll use these area models, but I'm going to use them more to check. So we'll practice a little bit together, but then I'm going to use them to check more than I am to actually make it into a simplified fraction, okay? So what we're doing, usually when we look at this, we've started with the big fraction, right? We've pretended that these extra lines are in here. Well, this time, you're not doing that. You're starting with exactly what they give you, okay? So how many squares or rectangles do you see to start with? 6. Is that my numerator or denominator? Denominator. Write that down. How many are shaded? 3. Okay, so when you look at that fraction, you're going to see fractions that look like this, and they're going to say, I want you to simplify, reduce, or rename this fraction. You want it in the smallest fraction possible, okay? So you'll use this a lot with fractions when you are adding, subtracting, multiplying, dividing. We won't do much of the multiplying or dividing this year, but you'll use it. Whatever your answer is in a fraction, you always want to simplify it. You always want to make it as small as you possibly can. So using the area model, now they want you to look and see, well, how big of a block can you make? Okay, so if you look at this one, they started with 4s. Well, then they said, hey, look, you can't really erase these lines that they put in, so they put a bigger box around. They said, oh, I could make this into 1, 2 boxes. So that's what they're wanting you to do. Now, in my mind, that's a little bit harder. If I could erase lines, maybe that would help me. So I'm going to show you, but I don't want you to get confused. If it makes perfect sense, if you're visual, I'm visual, but that doesn't work very well for me. But if you're a visual learner and you say, oh, I see it right away, then do it and use it. If you are not, or you look at it and you're like, oh, this is kind of confusing, then you're going to use the method I'm going to show you. But I do want to show you on this so you have a visual too. So if you kind of look at it at mine from further back, we can see all these lines in here, but I can't in here, okay? So what you're saying is, oh, I just want to put this box around here. I could box those in. Now instead of having 6 parts, I only have 2 parts, okay? Do you see how I did that? It's okay if it's confusing. Write that down as your denominator. Leave some space in there. Now, if I only have 2 parts, how many are shaded? 1. Okay, so this is what I want you to get to, because this is a lot like yesterday. Yesterday, though, we were multiplying, right? We made some equivalent fractions. This time, you're going to look and you're going to divide. Well, hey, look at my denominator, 6 and 2. How are those related? I can think of the factors, what goes into 6, or I can look at, hey, well, how did they get from 2 to 6? Okay? The tricky part is that has to work with the number in the numerator also. All right? So we're going to start with this one, and then we're going to move on to where we really have to look at both the numerator and denominator. So just look at 6 and 2. How are those related? 2 goes into 6. How many times? 3. Okay? Look at the numerator. Can the numerator be divided by 3? Yes. So we're going to show that we divided both the numerator and denominator by 3. Remember, you have to divide or multiply by the same thing when we're doing this, okay? So when you're making an equivalent fraction, you have to multiply by the exact same number. When you are simplifying, you have to divide by the exact same number in the numerator and denominator. So 3 divided by 3, does that equal 1? Yes. 6 divided by 3, does that equal 2? Yes. So then these are equivalent fractions, 3/6 and 1/2. But what I've done is simplified it. I've taken it down to the smallest numbers. Can I divide 2 by anything and get a smaller number? I can divide it by 2. 2 divided by 2 is 1. But can I divide 1 by anything? 1 divided by 2 doesn't work. 1 divided by 1 is still 1. It's still the same thing, okay? So what you're trying to do is get it down to what is the smallest fraction I can have with the biggest pieces, okay? So if you look at it from back here, kind of try to ignore these lines, you can see that they're all going to equal the same one. How many big pieces am I going to be able to make out of all of these? 2, right? So they're all going to equal 1/2, all right? So what I want you to do is, before we get any other drawing on here, I want you to pause for just a minute, and I want you to write what fraction they actually have with the lines in, and then check it with mine. All right, did you get 5/10 and 4/8? Okay, now draw the big boxes around. We can see, oh, we were able to make 2, okay? The thing, that doesn't work very well when you use your pen upside down like that. The thing that I don't want you to get confused on is they just gave you boxes that will all be able to go down into 2. Okay, that's not the way it will always work. So this is just a visual for you to see. So I want you to put the 1/2 over here. All right, now we have to find, what did they do to these? Okay, how are 10 and 5 related? 5 goes into 10 2 times, right? Okay, but can I divide 10? I did it again. This is backwards, isn't it? This is a 2. It looks like a 5 when I look at this. I'm very sorry. How are 10 and 2 related? It goes in 5 times. Can my numerator be divided by 5? Yes. So then I can use 5 and show that 5 divided by 5 equals 1. 10 divided by 5 equals 2. What I couldn't do is say, hey, I know another factor of 10. We said 2 is a factor of 10. Okay, well, I can divide 10 by 2. But can I divide 5 by 2? Nope, so I can't use it. Okay, all right, what about this? 8 and 2, how are those related? 2 goes into 8 4 times. Can 4 be divided by 4? Yes. So I divide both the top and bottom by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. So we've made equivalent fractions, but we reduced them. We made them smaller. Where before, we were taking a fraction, multiplying it by something, and making it larger to make an equivalent fraction. Okay? So let's keep working. Turn to the back side of that page. We're going to work on it before we really do anything with these, okay? So I want you to look at this. Look at how many they had to start with. 1, 2, 3, 4, 5, 6. 6. And then they gave you a number. They didn't actually shade them in. So just quick shade in 4 of them, okay? They gave you 4 out of 6, okay? So now that's what we have there. Kind of cover that up and look at it, okay? I want you to see how we decide what are we going to divide by when we don't have the model, okay? So what you do is you look at your numerator and your denominator and you think, what are the factors? And for a while, I write the factors down until I can do it on my own. So what are the factors of 4? What do we say? 1 goes in, 4 goes in, and it can be divided by 2. Okay, so I can write the factors of 6, or I can just look at my numerator factors. Everything has to be able to be divided by, the numerator has to be able to be divided by the same number the denominator is divided by. So then I look, I'm going to find what's the largest number that both numbers can be divided by. So 1, 2, 4, what's the largest number? 4. 4 can be divided by 4. Can 6 be divided by 4? No. Okay, what about 2? Can they both be divided by 2? Yes. So I'm going to use that. That's what they divided by. 4 divided by 2 is 2, and 6 divided by 2 is 3. Okay, so what you're looking for is the largest number or the largest factor that both the numerator and denominator can be divided by. okay? So when they did that, and they were able to say, oh, look, now I drew these big boxes around here. Now I have 3 big boxes and only 2 of them are shaded in. All right, so this gets a little more difficult, I think, using the model. So we're going to use the model here, the area model, afterwards. All right, so very quickly, I want you to pause. I want you to count how many boxes are in each and make that your denominator. Just write it over to the side. Okay, let's check that we have the same denominator. Did you have 12? Good. Very quick, shade in 4 across the top and write that in. Okay, did you have 10? Very quickly shade 5 across and write in 5 as your numerator. And then here, did you have 8? Very quickly shade in 4 across. All right, so now we're going to look at the top number. Look at the numerator. All right, think of the factors of that number. The first thing I always look to see is, hey, is that numerator a factor of the denominator? If it is, I don't have to go any further because that's the biggest number that could go into each of them. Can 4 go into 12? So then I can use that number. Divide both by 4. 4 divided by 4 is 1, and 12 divided by 4 is 3. Okay, so now I look and I say, hey, I was able to take 4 12ths, all of this, and turn it into 1/3. Now I can look and go, can I break this into 3 groups? 1, 2, 3. Yeah, there's 3 lines there. How many of them are shaded in? 1. That's how I can use the model to prove my answer. Okay? All right, look at this. 5 and 10. Now I can think of the factors. 5 is a prime number, so only 1 and 5 go in. But I can look and say, hey, does 5 go into 10? Yes, so I can divide by what? 5. 5 over 5. 5 divided by 5 equals 1. 10 divided by 5 equals 2. Okay? Do I have 2 lines and 1 of them shaded in? And I did it correctly. I simplified it. All right, do this last one. Does 4 go into 8? Yes. So, oops, I put equals. Divided by 4 over 4. Do that problem. Go across. 4 divided by 4 is 1. 8 divided by 4 is 2. Do I have 2 lines? Yes. Are one of them shaded in? Yes. Okay, those ones are kind of simple when the number easily goes in, okay? But it doesn't always work that way. If the numerator does not go into the denominator evenly, then you have to list your factors out and find what's the biggest factor. So like if I had 10 over 16, let's say that was my fraction, I can look at the factors of 10. Well, can 10 go into 16? No. Can 5 go into 16? No. Can 2 go into 16? Yes. So then that means I can only divide by 2. 10 divided by 2 would be 5. 16 divided by 2 is 8. So my simplified fraction would be 5/8. Okay, let's just keep practicing. We're going to practice, you're going to work a little bit, and then you're going to do it on Zearn. Okay, so look at this next page. It says, in the first area model, show 2 6. I don't want you to do the area model first. I want you to write that fraction down. 2 6. Okay, in the second, show 3 9. Look how they write it. You just have to read it and then hear the fraction. 3 9. Okay. Show how both fractions can be renamed as the unit fraction. Okay. So they used renamed, circle renamed. That means simplified or reduced. All right. So let's look at each of them. 2 divided by, or 2 over 6. Can 2 go into 6? Yes. So that's the largest factor. Divide both of them by 2. 2 divided by 2 equals 2. 6 divided by 2 equals, goodness, what's with my brain today? 2 divided by 2 equals 1. I heard you. That was it. 6 divided by 2 equals 3. Okay? Now, I don't have to worry about these numbers. I'm only looking at 3 9s. What number can go into 3 and also into 9? 3. 3 goes into 9. So I'm going to divide both by 3. 3 divided by 3 equals 1. 9 divided by 3 equals 3. If you're struggling with the division, you need to either use your multiplication chart or just think of the multiplication factors or the multiplication facts you've learned and go backwards. 3. What times 3 equals 9? So working on missing factors would be a really good idea. Like 3 times what equals 9? These ones. Because then you have to think, what times 3 equals 9? Or 9 divided by 3 equals 3. Okay? Look, we rename them to the same fraction. Now you can go back and draw it if you want in order to prove it. But that's only up to you if you want to. All right? I want you to do number 4 by yourself, but let's just set up the fractions. It says in the first one, show 2/8. Write that fraction down. And the second one, show 3/12. Write that fraction down. And then show how both fractions can be composed or renamed. I want you to circle those. What does that mean? What's another word? Simplified or reduced. When they say composed, they mean this. Before we had been decomposing. We had been saying, hey, we have 2, decompose it into something smaller. Now they're giving it in the smaller and you have to compose it, put it back together into something larger. Okay? All right, so this one is for you to work on. This is on your own and check it after, either with a partner or with your teacher. I want you to turn to the back. I'm going to show you how to do it, and then you're going to work on it on your own. This says use division to rename. Circle rename. What's another word for rename? Simplify, or another word, reduce. Use division to rename, simplify, or reduce each fraction given below. Draw a model if that helps you. Underline if that helps you. If it works for you, if that helps you check it, then do it. See if you can use the largest common factor. So that means look at the numerator. Ask yourself first, always, because this will save you time, can the numerator go evenly into the denominator? If yes, that's your factor, that you're the largest common factor that you are going to divide by. So look at, let's look at each of these. Can 4 go into 8? Yes, so that's your factor. You can do that one. Look at B. Can 12 go into 16? C. Can 12 go into 20? D. Can 16 go into 20? So that means we have to write out the factors. Okay, so look at letter B, 12. What are the factors of that? 1 and 12. You already know that, so write them down. Okay, what else? It's an even number, so 2 and 6. What else? Pause it if you're not sure to think about it, and then I'll tell you. 3 goes in. How many times? 3 times 4. Those are all factors of 12. So now you're going to start over here at the 12, looking at 16. We already said 12 can't go into 16, so cross that out. Can 6 go into 16? Cross it out. Can 4 go into 16? Yes. So I don't need to look at any other ones. I found the factor that's the largest. So now you're going to write it down over here. I guess it would have been smarter if we would have moved that over. We wouldn't have to rewrite it. So on the next ones, maybe you do that. And you can do your division right here. But you're going to divide both the numerator and denominator by 4. And that will give you your simplest fraction. Okay? Your smallest one. Then go on and do this one. You already have the factors of 12 written up here. And then here, letter D, do the factors of 16. and see what is the largest factor of 12 that also goes into 20. What's the largest factor of 16 that also goes into 20? All right, practice those and then do Zearn for lessons 9 and 10 and get some practice with those.